Hey guys, welcome to the Outer Nexus. Tonight, we are going to check out new space startups, nuclear powered rockets. But first, we're going to start with space barnacles. Let's check this out. Strange sphere studded rock found on Mars by NASA's Perseverance rover. Um, NASA's Perseverance rover has encountered another rock on Mars that has left scientists puzzled. Named St. Paul's Bay by the mission team, the Mars rock features hundreds of millimeter-sized dark gray spheres, some of which have tiny pinholes, like barnacles. The Perseverance discovered this rock on March 11th on the rim of the Jezero crater, an ancient lake bed that the rover has been exploring since 2021 for signs of past microbial life. Scientists say determining the geological origins of this area's feature could provide valuable insights into how the rocks evolved over billions of years. So let's get a better view on this thing. Billy, is that a space barnacle? Is that a cracked off plate of space barnacles at the bottom of an ancient lake bed?
Most likely not. So, no. Like, the whole thing about aliens, including micro aliens, is it's not aliens until it's aliens.
Listen, barnacles are not micro aliens.
Yeah. Okay. So, most likely, and I think this is even touted somewhere else, is that this was the effect of heating and cooling over a long period of time.
Yeah, I think what they said is that it most likely resembles, just like what you said, and the like bubbles from volcanic activity, just like solidifying from hitting the water, and that would make sense. That would make a ton of sense.
Yeah,
and it could be barnacles.
But it could be barnacles.
But let's get into the main point here. So it looks like, I'll just throw this up here. This is from MIT Technology Review. Rivals are rising to challenge the dominance of SpaceX. Startups and legacy aerospace companies alike are aiming to take a chunk out of its launch business. SpaceX is a space launch juggernaut. In just 2 decades, the company has managed to edge out former aerospace heavyweights Boeing, Lockheed, and Northrop to gain near monopoly status over rocket launches in the U.S. It accounted for 87% of the country's orbital launches in 2024, according to an analysis by Space News. Since the mid 2010s, the company has dominated NASA's launch contracts and become a major Pentagon contractor. It is now also the go-to launch provider for commercial customers, having lofted numerous satellites and 5 private crewed space flights, with more to come. But now there's other space companies coming in. Other space companies have been scrambling to compete for years. But developing a reliable rocket takes slow, steady work and big budgets. Now, at least some of them are catching up. A host of companies have readied rockets that are comparable to SpaceX main launch vehicles. The list includes Rocket Lab, which aims to take on SpaceX workhorse, the Falcon 9, with its Neutron rocket, which is pretty awesome. We'll get into that, and could have its first launch in 2025. And Blue Origin, owned by Jeff Bezos, which recently completed the first mission of a rocket it hopes to compete against SpaceX Starship. Some of these competitors are just starting to get rockets off the ground, and the companies could also face unusual headwinds, given that SpaceX, Elon Musk, has an especially close relationship with the Trump administration and has allies at federal regulatory agencies, including those that provide oversight of the industry. And a lot of people have been claiming that this kind of relationship he has with the White House is going to create regulatory capture. And that's a little concerning. If all goes well, the SpaceX Challengers can help improve access to space and prevent bottlenecks if one company experiences a setback. And that's the point. That's the point of having a nice, robust capitalistic market. So you don't just have one organization dominating everything. You don't just have like defense contractors or NASA or just SpaceX dominating and monopolizing all of these platforms. You need multiple different ways to do this. More players in the market is good for competition, says Chris Combs, an aerospace engineer at the University of Texas at San Antonio. I think for the foreseeable future, it will still be hard to compete with SpaceX on price. Let me see.
I mean, one of the big things here is price.
Yes.
And like you said, it can create regulatory capture where you kind of get one company that's just winning all the contracts.
Yeah.
It's not always a good thing, but it can be helpful on occasion when the price is right.
When the price is right. Yeah.
And the whole point is that if we get a whole bunch of companies able to compete, that it'll drive the prices down. It drives
innovation too.
It also drives innovation, but it also drives prices down because they're going to be competing to see who can have the least cost for doing a thing.
Yeah.
So that's what we're looking for. Right now, like you said, SpaceX kind of has, almost a monopoly on the whole thing.
Yeah.
The way that they came about was, they came around in the 2000s. They always had contracts, but they were smaller contracts. And even though they failed in a lot of you do have to remember they failed in a lot of their first attempts.
And that's the point almost.
And the company basically was about to just go belly up.
Yeah.
But that's when Elon swooped in.
Oh, yeah.
And started, here's the money, keep it going, and we'll see where this goes.
Yeah.
And through that, SpaceX was able to thrive into the company we now see.
Yeah. And in the late 2000s and early 2010s, NASA just wasn't doing anything. They just had empty launch pads. And basically, I think Obama was the president that allowed SpaceX to start, allowed NASA to start contracting their space pads out to SpaceX. But yeah, the main point of doing this and this whole market is, it just reminds me of the computer industry from the 70s to the 80s to the 90s. I mean, here's the thing. We had working computers back in the 1950s, but they were warehouse size and they were basically government projects. And then by the 80s, people had personal computers in their homes and they were incredibly expensive. They were very, very expensive. I remember I used to work for a guy that he would go to these conventions in the early 90s and sell computers there. And some of these computer systems were $50,000 to $100,000. And these were super high-end home computers in the early 90s. And laptops I remember this commercial for this 1989 laptop. It was like $80,000.
Well, you also have to remember like those little ads that came in like newspapers and stuff, for like even the companies that we know now, like Staples and whatnot. They're showing the home computer.
Yeah.
And even back then it was like $5,500.
Yep.
And that's not uncommon to see for these these types of computers.
Oh yeah. And that's the thing. Like, rocket fuel is always going to be expensive, but if we can get the stabilization technology for these rockets squared away to the point where we could just keep reusing them, we could just keep catching these rockets, stabilizing them with AI, and just keep using the same bodies. I mean, it's just going to get cheaper and cheaper and cheaper. Space will get actually much more accessible, and it'll become not just some pipe dream. It eventually will be something that normal people can probably go up in. I mean, and again, like I said, with the rocket fuel, I feel like the rocket fuel is the last biggest hurdle to space flight like this that we're doing. So it's really interesting to see that this UK startup, hold on, let me pull this up. And I think Lockheed Martin is doing something like this where it's nuclear powered. I guess this isn't nuclear powered though. This is fusion powered.
Oh,
That's nuclear powered. Yeah. This fusion powered rocket could have the time it takes to get to Mars. UK startup Pulsar Fusion has unveiled the design for the Sunbird concept spacecraft. And look at that. Look at that. It looks like a sci-fi spacecraft. That's what we're talking about here. That's what we need right there. Something that looks like a submarine that goes in space. So interplanetary travel might be about to get a whole lot faster and hotter. UK startup Pulsar Fusion today unveiled Sunbird, a nuclear fusion powered rocket concept that could half the time it takes to travel across the solar system and maybe beyond it. Machine learning models show the rocket could potentially propel a spacecraft with a mass of about 1,000 kg or 2,200 pounds for us Americans to Pluto in 4 years, less than half the time it took NASA's New Horizon mission, which was powered by regular ion thrusters. Earth to Mars, 4 months. Earth to Saturn, 2 years. Rather than launch from Earth each time, several sunbirds would be docked in low Earth orbit. Here we go, ready to attach to spacecraft and propel them deeper into the cosmos. That's fucking awesome. Sunbird would be fitted with a dual direct fusion drive, a compact nuclear fusion engine, which could provide both thrust and electrical power for the spacecraft. Pulsar started building the engine in 2023 at the site in Milton Keynes, England. Static tests are slated to begin in 2025, followed by an in-orbit demonstration. Oh, man. Of the core technology and components by 2027, the company said. When fired, the engine could temporarily become the hottest place in the solar system, creating exhaust speeds of more than 500,000 miles per hour from UK to Mars. Founded in 2011. All right. What do you think about this so far?
All right. So I think one of the important things to point out,
it seems sensational. I'm losing it over here.
So it keeps saying, like, it can half the time. It can half the time.
Mm-hmm.
And the reason it can half the time is because a lot of what we do now is, like, if we're going to Mars, we plot out where Mars is going to be when we are going to intercept it. You burst your engines as high as you can. And then you drift. You drift to Mars. And unless you have an ion engine, which basically puts out a low power, constant push the whole time.
And it's nuclear powered. That's the key.
Yeah. This is putting out, unlike drifting, I'm assuming they're going to pulse it. Which means they're just going to constantly give it another push to keep it going faster and faster in the way that it's going. And that is what's cutting the time. I think it's where everything's eventually going to go.
I feel like it has to, because like there's no actual reason to not make these nuclear power, especially if these things are just going to stay docked at the International Space Station. There's absolutely no reason for them not to be nuclear powered.
No, and one of the other parts about it too is like, okay, well, here on Earth, it's like, oh, there's nuclear waste. You're in space.
You're fine. Nothing's gonna happen.
Nothing's gonna happen. Guess what? It's radioactive out there too.
It's radioactive out there too. You have to have nuclear shielding.
Yeah.
No, I mean, and I think that we will see more concepts like this come to fruition, and I hope we do. Let me read a little more. Founded in 2011, Pulsar has spent over a decade on fusion research. More recently, the company started developing 2 other products in parallel: a Hall effect electric thruster for spacecraft and a second stage hybrid rocket engine. Pulsar has built a reputation in this industry for delivering real technology, not just talking about it, said CEO Richard Dean. We've recently commissioned not one, but 2 of the largest space propulsion testing chambers in the UK, if not all of Europe, and we have ambitious plans to grow from here. So it's actually kind of impressive that Europe is taking a head start on this kind of technology, and we just don't. We're just acting like we don't have anything like that.
Well, here's the thing. Not that, and I do kind of agree. Like we should have something to this degree.
We should have something.
To this degree somewhere. But I think the other thing that we're trying to get to is, like, they're saying a fusion reactor. Like, I think what we're trying to get is the larger fusion reactors going. Like, here on Earth, that you can then take into space and power a very large craft.
Yes.
I think that's kind of what we're more aiming for. Not that you can't use it on smaller stage stuff like they're doing here. It cuts
Yeah.
time. It's very nice.
Yeah.
But I think, when you get that larger one going,
Mhm.
where it's like, oh, you can take a whole bunch of people or a lot of material to one spot all at once,
Yeah.
and at good speed.
Yeah.
I think that's better.
Yeah.
Also, when you have a fusion reactor of a larger size like that,
Yeah.
granted, I think this one will probably put out a big one too.
Yeah.
It generates a very powerful magnetic field.
Oh yeah, that's what this is about to get into. Yeah.
And when it does that, I mean that it's not going to stop everything,
Yeah.
but it stops some things from even getting to the
Yeah.
ship, or
Like
at
a
least deflects it enough.
like a force field.
Yeah.
Let me see. While Pulsar's goal is to build and test a fusion reactor in space in just 3 years is certainly ambitious, advances in AI could help. The company has teamed up with US-based Princeton Satellite Systems to predict how plasma behaves under electromagnetic confinement. The machine learning simulations will guide the rocket engine's design. Yeah, so that, but that would lead right into this. Well, and it doesn't directly lead into this, but the debrief, I don't know, I'll throw this up there. It could lead into this. The brief came out with an article, Warp Drive Think Tank adds Harvard astrophysicist and warp theorist to advance planetary defense. Let me see here. So they have Avi Loeb and Sean Fell, who Avi Loeb is a Harvard astrophysicist. He's a doctor for Harvard. And he causes a lot of shit with Harvard for his opinions. He thinks that Oumuamua is an alien spacecraft that came in and checked us out and went back to the fleet or whatever. I think he's onto something there. I think Oumuamua was not natural. I don't think Oumuamua was a natural object. It just, if you look at what it was, it just didn't move in a natural way at all. It literally bounced out away from our orbit. But they think that they can create a warp drive, I think based on the Alcubierre drive. I believe that's what it is. I can't really find it in the article, but what do you think about stuff like that, Billy? If eventually we have warp drives.
I mean, so warp drive is one way of just putting like faster than light travel.
Yeah.
And there's a lot that goes with that. It obviously also starts bringing up, questions of, time, like what time means in certain factors, because if you go faster than light, technically time stops when you go that fast. But if you're moving
outside of time,
well, if you're moving relative, like, oh, we're not moving, but the bubble is it.
Yeah.
There's weird questions brought up there too.
Yeah.
But if you can get up to like near light speeds, you could come back. For you, it was a couple months later, a year later.
Yeah.
For us, maybe 300 years later.
Yeah.
And be like, oh, 300 years of advancements.
Yeah.
What's happening with you guys now?
Yeah.
So I think there's some cool things that can be done with that.
There would need to be some sort of timeline stabilization or something. You know what I mean?
Well, I mean, it starts bringing up that kind of question where it's like, we sent that ship out like, a year ago. We sent that one out, 10 years ago.
Yeah.
They're coming back. It's been hundreds of years for,
And that is the theoretical problem with generational ships, is a generational ship is a spaceship designed to host generations of humans over hundreds of years so that they can travel conventionally to another planet. And the theoretical issue with that always is you could send the generation ship out, and then maybe 10, 25 years later, the planet that you sent it out from, well, they just invented warp drive and they already got to the planet that you're trying to get to. And, hundreds of years later, the generation ship will arrive at that planet and they'll be basically a different society than the people that made it there first. Does that make any sense?
Oh yeah, no, and that was always kind of the thing brought, not just for generational ships.
Yeah.
That's for technology in general.
Yeah,
'Cause-
Interstellar goes over it. Yeah,
Yeah, because if you send something out
yeah,
and it's traveling as fast as it possibly can,
yeah,
your technology is going to advance more,
yes.
and then your new fastest ship can get there faster than they're going.
Yeah, exactly.
And it's like, oh, okay, so you have this. It's not a paradox, but you have this like,
But
oh,
here's maybe a cool sci-fi idea. The humans on the generational ship are like preparing to get into war with the humans that got there first, and that would be a cool sci-fi.
There's
scenario.
there's a sci-fi
There's a sci-fi
movie
novel
there,
in that.
right?
But how about this? Okay, this article with the fusion rocket, yeah, the Pulsar Sunbird fusion rocket, they're saying Saturn in 2 years, Pluto in 4. Put the teleoperated humanoid robots in those ships. Which planet do you want to work on for your day job? You go into an office down here, and then you put on the VR goggles. You're on another planet. What planet in the solar system do you want to be a construction worker on?
I mean, it's like if you like land, you're
Yeah.
probably gonna be. It's almost Mars all the way.
Well, yeah, there's Mars, but
Um,
you like besides Mars, like Moon, Europa, the asteroid belt, all with humanoid robots.
Europa's a big one for me.
Yeah,
But because of where we are
Yeah.
in the timeline,
Mm.
I don't think we're necessarily gonna see any of like Europa
yeah,
getting way advanced.
yeah,
On the other hand, we might be in the generation that gets to see the moon. Like from Earth, you look up at the moon and there's lights.
there's city up there.
There's cities up there.
Yeah,
So
Oh,
we
man,
could
that'd
be that
super-
one.
That'd be super badass.
And so I would say the moon.
Yeah,
And just to see.
I mean, yeah, I think the moon is a given.
Yeah.
We're going up to the moon for
Yeah.
sure. That's happening. But man, if we could send, I almost feel like if we can get to the moon and set up a base there real quick, the other planets are kind of in the bag at
Yeah.
that point. That's what I feel like.
Yeah.
They've
And if you're
figured out.
teleoperating,
Yeah.
truthfully, you could just. I don't see why you couldn't just be like, you know what, for a couple days, I'm going to go over to Europa.
Yeah, exactly.
Yeah.
Total Recall.
Yeah.
Visit other planets. You know
Mhm.
what I mean? Yeah.
But I mean, you could do that, and there's other cool things that you could do too with it. Like there's fun things you could do.
Yeah.
With teleoperated robots.
Yeah.
So there's a lot that can be done with
Yeah.
that kind of thing. So
Yeah. But we don't need to get into that now.
No.
And I think that's a wrap. Remember to like and subscribe, guys. See you next time.